Welcome to the second part of our, let's say, tutorial. I want to say introduction. There's two things that I want to go over. One is modules, and the other one is using the queuing system, which is really how you should be running things on an HPC system. Now, just trying to figure out which way it's better to show you modules first or Slurm. I am going to go with modules because the slide is already up. So we talked about our shell and the contents of the environment variables. So we need a way to modify those variables and to customize our shell, mainly to be able to access the different software that is available on the system, the different versions of software that is available on the system, the different compilers, the different versions of compilers, the different versions of software with a given version of a compiler. Quickly, that becomes an intractable problem, right? So you want to, what we do is we use these environment modules. These are not to be confused with Python modules. These are not to be confused with kernel modules or any, these are environment modules. So these are typically commands that we run, and those commands change. Well, the main thing that they change, remember our path variable? And there are a couple more. Lib. It's not even said already. It doesn't really matter. I call path. So consider this. We have this piece of software that is installed in our system. Usually it will be installed in, under user bin or user local bin if the system administrator set it up. If you set it up yourself, in the best case, it would be under your home directory in slash. Yes. Never mind. It would either be in /bin or whatever other place in your home directory. If you had another version of your software or some software, and then another, and then you compile that with a different version of a compiler or another compiler altogether, then you want to keep those separate, and you want a way to access them. So the executable will probably end up in some directory of your installation, and what we do on our system is actually create a module that changes this path to actually see what you want to be seen, right? The right versions of things. So first, so one of the things that you will be using on a system is a compiler. Actually, why don't we take a step back? Let's not go to the compiler directly. Most of you know what Python is. And we talked earlier, at least in the break session, about Python and how we can use Python. For example, to create to have Python execute our script. So if I say Python on my system, sorry, I also added a -v so that we can see the version. Doesn't really matter. This is this is Python. I don't think we need this. Let me make this bigger. Yeah. This is Python. This is the system Python. If I say which, you can, /bin is like the default place for binaries. Even that's actually used a bit, but it doesn't really matter. Excuse me. This is on the system. What if I wanted a Python 3? Because you see, this is a Python 2.7. This is a CentOS 7 dot something system. So it still has 2.7. I can do a module. And why don't I bring this back? Let me. Okay, I can do module load Python. Tab completion works here. So I can pick one of these Pythons that is installed on my system to use. So if I wanted a Python 3.7 something, I can do this one. Don't worry about all of this at the end. We'll get to that, hopefully. Now, if I say Python, give me the version, now we're using Python 3.7. That's what we loaded. But what really changed? There's no real magic here. But what happened is that this path was just simply modified. So what if we look at it? Right, path. This is long.
George.
Yes.
I was trying to follow you.
Yep.
And I did module load Python, but it didn't give me the option. But it from Python 2.7.5 automatically it made it to Python 3.8.2. I don't know if it's a problem, but I was just wondering how come it did.
It's not, and I'll get to that. What you did by not specifying, by just saying this,
yeah,
you just did this, right? That will load the default, what we want the default Python to be.
Okay. How come before when you inputted the command module load Python, it gave you all of that list? What was the difference between that command and this command?
Apologies. I mentioned it, but maybe I mentioned it in passing. I wasn't hitting enter. I was hitting tab.
Oh,
if I did double tab, it will actually try and autocomplete for you. So if we have the system set up in a way that, so if I just type this and do double tab, you can see it can be any of these things. It doesn't have to be Python. It can be PyYAML, right? This other thing. So if I just go even just lower, sorry, so double tab, these are all the modules that start with P. Okay, so that's just the double tab. It wasn't an output of the command. And I can do slash and then keep going. And then I can say, I want something from 3, double tab again. It gives me the options that I can use, right? We don't have a 3.9 yet. We have an 8. And that's, sorry. And that's it. Just loaded Python. Disregard that output for now. So let's go back. This is the one that I loaded before. There you go. Right. Now I can see what's loaded. Now what we have set it up in such a way that if you load Python 3.7.4 using this version of the GCC compiler, we'll get to those details in a bit, it will automatically load all of the following files. Because most of these are basically dependencies for this Python. There are other reasons of doing so, but bear with me. So we've covered module list, which gives us what's loaded. We can look at module. No, this one I won't pick. Module avail. This gives me all of the available modules on the system. There are plenty. There will be many, many more. Like there are many, many, many modules. At one point on our previous system, Cytera, we have close to 2,500 modules by the end of its lifetime. We will try to not do that this time around. You can also see that we can also do module avail Python. If I put a slash at the end, it will only check at the beginning, so up until the slash. So it's really useful. So if I do module avail Python with a slash at the end, we have a few. This is the default one. By the way, for existing users of the system, this is a new build set, a new set of modules that I created very recently. So you may not be aware of this. But anyway, all of our modules are under here. This is not something that you need to know per se. When you get more advanced, we might point you to a different set of software because you requested something very specific, but we'll get to that. All of this is configurable. It's very flexible and it gets very, very complex really, really quickly. But once you know the basics, you can figure out what's going on. What's interesting here to see is, let me see. These are all the modules that start with Python. This is the default module. When you did just a module load Python before, without specifying a version, this is what will be loaded. So doing module load this or this is really equivalent. Okay, so this and this are equivalent. Before I had a different one loaded, that's why you didn't have this loaded symbol here. So this is saying that this Python module is the default and it's actually loaded right now. You can purge all the modules. Sometimes you want to start fresh, because right now, if I do a module list, there's a bunch of things in there. I can try and module unload Python. But there are so many, I want to get rid of all of them. I just say module purge. And now there are no modules loaded. To get a full listing of the, all of the commands that you can do with modules, you can do module help. And if you want to look at a specific package, the Python one is actually, interesting to look at. We can do a module help Python. We can put the specific version if we want. So 3.8 tells me a few things about the module. I mean, it's not a man page or anything, right? It's not a manual page. It says what Python is, nice. But the one for Python also includes the extensions that we have already installed, right? They are modules with we call them extensions in this context, but that's a different story. There are a few. Let me just quickly go over the couple more interesting commands here to use, and then we'll go a bit deeper into what it means to actually load a module and what happens to the environment. And then hopefully I'll allow more time for exercises this time. So this other convenient tool is almost like a shortcut. It is a shortcut to module to the modules command. If you say ML, it's the same as module list. Say module load. Just going to load the default GCC. Got. I can module load as module purge. Let's purge it again. So everything gets removed. I can again load it like this. If it's on its own, it's list. If it's like this, it's load. If I list it, so by loading the default GCC compiler, I am also getting basically GCC bin utils and zlib. This you can disregard for now. You can unload modules, but those are, there are many things that you can do. The man page or doing module help is helpful. And you can find a lot more on what you can do with modules on the online documentation. If you just do, if you just Google environment modules, that's probably the first thing you'll find. So I wanted to, oh yeah, one more thing I wanted to show you about modules and how they really affect the environment. We talked about how the path changes, right? So let's make sure we don't have any modules loaded, and let's echo the path. Let's do some massaging here, just to replace all the columns with a new line just for the sake of output. This would be in the previous session, but anyway. So I'm just splitting that up and displaying it like this. Now, if I do a module load, let's load something simple. I want something small. No, let's check which GCC compiler would be used if I just did GCC. This is the compiler. Which compiler is it trying to use? It's trying to use the system compiler. We generally don't want to do that, right? We want to use one of the module-based compilers. It uses GCC because it found it, just went down this list, checked in libexec, in L1 libexec, checked in user local bin, didn't find it. Then it checked in /bin/GCC, and that's what it found it, and that's what it's using. So if I want to use a module-based compiler, not the system one, and let's check what GCC compilers are available. I have GCC 5.4, 6.3, 6.4, 7.3, 8.2, 8.3, 8.3-something. And then I have another set that I have, this is duplicate, this is fine. These are actually the same. I also have the latest version, which is GCC 10.2. It's also the default. Cool. Let me bring one of those in. I'll just load the default. Oh, AB load. We see it's loaded, and we can check our path. And now we can see this was in there before. Sorry. What's wrong with my keyboard? Oh, there you go. This was there before, and this is new. And if I now say which GCC, this is the one that is going to be used. And if I check, this is GCC 10.2. Trying to think if there is anything interesting to say about modules. Oh, yes. Let's talk about what we call tool chains. We have, let's start out with a clear. Any question until now? Nice, everything was crystal clear. So,
George, I have one.
Sure.
Everything was crystal clear, but I don't know. I think it's because I'm an absolute beginner. I still didn't understand the purpose of a module.
Look at it from my perspective. You want a specific compiler. Hey, George, I want this new GCC compiler that runs my code 10 times faster. Doesn't usually happen, but whatever. And somebody else calls me, says, but look, my code doesn't work with this new version that you want to install. And we're talking about compilers now. This is also applicable to all kinds of libraries, all kinds of software. How can I provide both of these on my system? And that is by using these modules.
Okay.
Right? it's a key way, actually, I want to say its main purpose, at least from my perspective, is to avoid conflicts. And it tries its best to avoid conflicts. For example, you cannot have the same module, but a different version, let's say, loaded at the same time. So you saw, for example, some of the output before, which I told you to disregard. So we have a blank module list now. So there's nothing in there. So if I do a module avail, I want to just, I'm only interested in GCC right now. I have all of these. So say I load this one. Now I have a GCC version. This is what I need. Cool. But suddenly I want a newer version. I just go with this one. I could have just said GCC, it's a default. Now what LMod, or this is the software that we use for handling modules, did was the following modules have been reloaded with a version change. So this one was changed to this one was changed to this one, and this one was changed to this one. Why do you need that? Because GCC does not work with an older bin utils package. Actually, if I didn't have modules and I was using the bin utils package that is on the system, I couldn't provide GCC GCC version 10 for you guys. The only reason I can provide GCC 10 is because we have modules. Okay. Otherwise, I would be dependent on whatever was on the system. So this is the main use for modules.
Okay. Makes a bit more sense.
Any other questions?
Yes, one more question.
Sure.
What does really mean each line when you printed the path? What does each line really mean? What does it correspond to?
Yes, the path variable is quite an important variable, right? It's where the system, and what I did was actually try and break it like this, right? My shell has currently a variable called path in it. If I type a command, GCC, this is a command, okay? It will start going through this list to find this command. It will check in blah, 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 /bin/GCC. If it finds it there, it will execute it. If it doesn't find it there, it will move down the list until it finds it. If it doesn't find it anywhere, it will say no such executable found or whatever.
Okay, clear. Thanks.
Welcome. So I want to actually stop talking about modules now. We have 1 hour left. Am I right, Stelios?
Yeah.
And I'd like to. Are we going to go? I don't think we need a break. Do we need a break?
Well, it's 90-minute session, so I don't think so. I think it'd be fine.
Okay, no break. Excellent. Actually, we should next time we should arrange for breaks every 45 minutes, I guess, because turns out that online sessions are actually more tiring than in-person ones.
Well, we can break in 15 and then
look. I have a couple of exercises,
more.
and we can take it slow during those exercises or whatever. Cool. Now let's talk about something that's more core to HPC, okay? And we'll talk about how we can use, Let me bring up my slide. Yeah, not much of a slide, but we're going to talk about Slurm. Slurm is our queuing system. This is what allows us, allows hundreds of users to share a big computer. This is what allows you to fire and forget 100 different computations, and system will actually take over queuing them, making sure that everybody gets a turn somehow, depending on some priorities or whatever, and then we'll execute it and somehow get you your result back. So let's dive into Slurm. I have a lot more commands that we can use with Slurm, but I guess we'll come up to those along the way. Oh, there you go. And actually, yeah, let's just keep it here. So first command you need as info. Give me some information about the current state of the cluster. This won't be your main one. And let me make this bigger. Your, let's say, go-to command would be sq. It gives you the current status of the queue, what is currently queued for execution. You can append the -L at the end, gives you some more, slightly more information and a bit more, full text other than this. So let's try and look at it a bit in more detail. Let's take first line here. Every job on the system gets a job ID. Makes sense. This is also saying that since the birth of this system, actually since the Slurm was installed, there have been 54,922 jobs submitted, right? So when I submit a new job, I will get a number. This job is actually sent to the GPUs to be executed on the GPU nodes of the system. That's what it's saying. The name of the job is actually this. Doesn't really matter. This doesn't matter much. It's for you to be able to tell your jobs apart if you have multiple. This is what it was submitted by this user. Its current state is pending. It's waiting. It's not actually running. If we look at the other ones, for example, the one from Jakob, it's running. And since that's not running, let's continue with this line. This started 7 minutes and 2. What did it? Yep. That started 8-9 minutes ago. And the user was nice enough to set a time limit on the job, saying that, look, it's not going to take longer than an hour for this job. So it was a way for them to give hints to the queuing system for scheduling different jobs. You can be, let's say, greedy and say, I want a whole day, which you might want, right? But if you don't want a full day, and this is what this means, and actually on our systems, 24 hours is the maximum you can have for a job. We can talk later about what you do if your job cannot finish in 24 hours, but that's a different story. They said, okay, this job, I'll need one node for 1 hour. This is what this job said. Or this one said, I need 4 nodes for a day. This one said, I need 1 node for 6 hours. And that was allocated. Allocated means a node was assigned to the job and it started executing. So this job is currently running on node CN08. CN on Cyclone are our CPU nodes. We have 2 types of nodes. We have CPU nodes and GPU nodes. Just a quick output. This is basically saying, oh, I hope I didn't mess up your sharing by resizing the window. Never mind this command, but it gives you some quick current status of the system. And these are all CPU nodes. These CPU nodes, we have 17 of them. And we also have 16 GPU nodes, like here. Colors. What the colors mean? Let's not get too much into that. Actually, this is my script, so that it doesn't really, mean much. These are blue because I reserve them to be used by us for this training. These are green because they are in use. These are white because they are not in use. But the colors are not standard or anything like that. Again, this is not a built-in command, okay? That's something I wrote. So don't look for this on other systems. So back to SQ. SQ. We should also mention that on our CPU nodes, we have 40 cores, right? So you should be running we have a couple of questions. Give me a few minutes and then we'll get to the questions. CPU nodes have 40 cores each, so there are 2 sockets and on each server, each with 20 cores. So they are 20 core CPUs. The GPU nodes have the same CPUs, but they also have 4 Tesla V100 GPUs with 32 gigabytes on each GPU. So let's do this. Let me maximize my screen just to give you a very quick overview on the architecture of each node. Tutorial. Okay. Bear with me, and you will not be disappointed. There you go. Let's move some windows out of the way. This is the architecture of one of the nodes, on the system, right? Actually, it's the architecture of all of the nodes on the system, except for the ones that have GPUs on them. I am sorry for the small lettering, but this is the machine. Like this whole box is the machine, right? And it has 192 gigabytes per node. And then this machine is made up of two what are called NUMA nodes, right? So if there is a NUMA node, or let's say the system is kind of split, each server is kind of split in half, one for each CPU socket. So just looking at one of these two, this one, this has 20 cores. So this one is a core. This is the core. This is level. These are the level 1 caches. This is the level 2 cache, which is just for one core. And this is the level 3 cache. That's 28 megabytes, and that's for the whole socket, right? And there are 20 of these on this socket. And then we also have another socket, which is the same, except that, well, actually both of them have that. They both have these. It doesn't say it here. Sorry, it doesn't say it here, but this is one of the GPUs. This is another. So these are the GPUs on one socket, and these are the CPUs on the other CPU socket. And the way that we have structured these nodes is that we have one really fast InfiniBand adapter for two GPUs on one side, and another InfiniBand adapter on the other side. You will remember from your introductions yesterday and mostly that, look, to make a supercomputer or an HPC system, what you need is really high performance interconnect. Yes, this is the actual architecture of the GPU node. This is you can get this using the ls-topo command, which you don't have access to because you have to load a module to do that. But we'll get to that later. And plus, right now we're not on the head node. Yes, I have a ready-made output on ls-topo.txt that you can use. What you really need is a high-performance interconnect. Let me. Can you see the screen? This is an InfiniBand adapter, right? This is an older one from an older machine, and that's where the fiber optic cable will come out. And this one is a 40 gigabit. This is like a 10-year-old card, and it's 40 gigabits, right? Your typical, networking today in your home maxes out at 1 gigabit. So this is a 40 gigabit one. And actually, it's not even a fair comparison. It's actually much better than 40 times better, right? Because it also has like 1 or 2 orders of magnitude lower latency, right? Compared to your Ethernet. Lately, there are better Ethernets, especially if you're talking about 100 gigabit Ethernet with direct memory, remote direct memory access. But that's a different story. So that's what allows that card is the interconnect is what basically connects the machine. It's what allows one node to exchange memory with another node. That's why you need that to be absolutely low latency and very high bandwidth. So that was just answering a question for those. So since we only have 45 minutes to go, let's get right to writing our first job, right? Is the size of the screen now okay? Because I had a smaller one. Now it's, you know, it's everybody can read it. You know, raise your hand if you have an issue reading what or seeing what I am typing. So I have a couple of examples prepared. There's one thing to really, let's go into that tutorial, Slurm. And go to an example. Actually, I'm going to VI it so we can get some. This is a job, right? It's not a really good one, but it's a job. When the whole purpose of spending, you know, some of today and you having to spend a lot more time to get better at writing batch scripts is because that is what we send to the queuing system to execute. If you want something done by the system, you have to put it in a shell script and tell the system, here's my script, go run it, right? Now, if I wanted to do, well, it's a shell script with some extra spices on top just to help the system out to do exactly what you want. So let's look at this one. Apologies for the dark blue. If you have an issue, please raise your hand for reading this. If I highlight it, doesn't really do much. So it's the same thing, but and all we're adding around it, all that's really necessary. Actually, none of that is really necessary. We could just submit the script and it would actually execute. But to have something at least basic in there, we specify parameters like say hints or messages or whatever you want to call them to this queuing system, to Slurm, by using this syntax. It's really simple. You just say in a comment, all these slashes at the beginning are comments, which I should have mentioned already. You say, you put in a comment, you say S batch, sorry, the S batch, and then you put a parameter in there, right? So that way you describe your job. Just to quickly show you what goes on, let me just go home, cd, takes me to my home directory, and let's copy that file so that I can use it. Why don't I just copy the whole directory? Somebody asked earlier, you know, what does recursive mean? I want a whole directory. From tutorial data Slurm, example 1. I want to place it in my current directory, or I want to place it in my home. And lo and behold, it is here. So if I go there, I can find a copy of the script that I can now edit, right? Because before it was owned by root, I couldn't edit it. Now, how do I just send the job to the system. Let's just do that. Let's go ahead and send it. We'll say sbatch, and then the name of the script. Please don't tell me that already finished. Yep. Yeah, let's do that. Okay. That was the output of the job. We don't. Let's do that. Let's make it run longer. Want to say hi and just go to sleep for 20 seconds. Okay, so it's just going to sit there wasting the node for 20 seconds. That's fine. It's for education. So the job was submitted. The ID of the job is 54970. SQ. That's my job. At least another person submitted the job. Let's see if anybody else submits. No, that's it. Yep, we got more people. Nice, excellent. So that was the first job. Let's go and look at it more. It was the name. The name was, it is self-explanatory, right? And we also, it's just for you to tell your jobs apart. The next one is kind of important, right? This is going to generate some output. Remember, this is going to be executed at some time, later on. It could be today, it could be next week. You don't know, it's a queuing system. Your session, your current terminal is not going to be around to take that output. Where do you want that output to go? Just say which file you want it to go to. If I don't do that, let me just comment this comment out. Okay, so this is no longer in effect. If I did this, that means it will disregard this line. Actually, why don't I just totally delete it to avoid any kind of confusion? So if I submit the job, I never specified where the output would go. This is from before. The job had an ID of 54980. So because I didn't say where to put the output, it just created one for me. And I called it Slurm 54980.out. If there are any errors by your job, there will be. So if the standard error was used for the output of your script, then there will be another file, slurm-5498.err. I'm wondering if at this point I really should, because we have 35 minutes left, I'd like you to actually go and try this out. This is probably the easiest and the hardest things to do, okay? Once you get this done, then it's all, once you're able to do this whole thing of, creating a job script and submitting it, then it's a matter of honing your skills. You can now do most of the things that you want to do. Then it's a matter of massaging your script to do the right things. And then we can talk more about how you get specific resources and all that. So let's do. Man is your friend, as in manual, right? Man, Slurm, all of that's there. Actually, there's a lot more. You actually have to go into SBatch where is it? To man SBatch. For all of the parameters. This is crazy big. You're better off going with examples. There are many guides. You can also access our own guide. I sent that link earlier, I think, and we plan, because the system is going into production in a month and a half, right? A lot of that documentation is going to be revamped before then. So you'll get more information and very specific to the system from our website on how you actually submit jobs. So let's do this. Let's get rid of this.
Can I quickly ask a question?
Sure.
In your batch script, you said that you have comments with the hashtag.
Yes.
But it seems that the cluster actually reads those parameters. How can I write my own comments to myself to remember what I coded?
You put an extra hash at the beginning, because
so two consecutive.
Two consecutive. Put a space. I always put a space between them just to make double sure. Yes, you can do something like this. Well, it was no. It was SBatch / output. What was it? I put it in the background. Just copy everything over and overwrite. Oh. Right, if I want to comment this out, I'll simply add another hash at the beginning. And please go out and just do this exercise. And if anybody has any burning questions, I'll take them now while everybody, let's just allow like 2-3 minutes for the exercise. You will need to take your time to make sure that, first of all, let's correct that typo. Just make sure that you are putting your output as per the instructions. Exercise 3. Right. So a couple of questions in the channel. How do you control that we managed or not? How do I check whether you managed or not? Is that what the question is? And the other question is, what is the reservation equals do 11? Yeah, cool. Yeah, I meant to actually go over this, but let's look at the wrong terminal. So in my job script, I have this extra line, right? Generally, well, on the system, you can have such thing as what is called a reservation. We generally reserve it right now for just our administrative use and for very specific reasons. For example, we have some of you may know that the Cyprus Meteorology Service, like the weather prediction that goes on, they use our system to actually run the model, right? That model needs to run twice a day, at morning and in the evening, so that the meteorologists at the Ministry of Agriculture can actually, do their prediction. But it's not our fault that they don't get it always right? The model is correct. So we need to run this twice, but we need to twice every day. So we need to reserve a set of nodes every day so that they are available. No other job is running at on those. So we can create a reservation. And I also did this for this session of our training. I didn't know how many other users would be involved or running on the system. It could be that we would get a big job and nobody could run anything. So I created a reservation. I mean, I can even show you that. You're not you're not expected to follow this. I can see the reservations that are on the system right now, and one of them is us. Right? Another way is a different meteorology service, and these are the ones for the Cyprus Meteorology Service twice, once in the morning, one in the afternoon, or the opposite. Cool. So make sure you are saying, it says batch submission failed, requested reservation is invalid. I don't know if we have anybody from ops to maybe help around with that. Make sure you are using edu 11, right? For your job. So any luck? Anybody having serious problems? This is going to be a prerequisite for next one. Let's see. Okay, we have at least 3 people attempting exercise 3. Somebody asked in Slack how I know what people are, because I am root and root is God. And I can check whether you created those directories or not. That's why I put it in there so you can see it on the bottom right. Cool. So moving right along, let's look at some other examples. Any questions, by the way?
How do you control the place where the output will go? you don't pipe it?
Well, you cannot pipe the output. Ah, wait, what do you mean? I am sorry.
I mean,
Output
you
of
can.
what?
Sorry.
The output of what?
Of your Slurm file.
Right.
So
yeah, go ahead.
I mean, in the command line, you could, in principle, forward it to a specific location, a file. But how could you specify that from your comments?
Cool. Let's do this quick one. Let me go back to not here, example. Yes. And let's do this. Well, this one says, I want the output of this script. This is my script, right? This whole script. I want whatever is outputted by any command, I want it to go to this file. This file is relative. If you submit it, it's relative to where you actually submitted from. So if I'm in my directory called example1, if I am in this directory, if I run the job, I will get my file here. What's more, remember, this is a script. I can do pretty much what I want in my script. And I can also do something like this. Echo a string into, and I can redirect it to /home a.txt or whatever. Or I can do more of this.
You could also, in the output.txt above, in the output equals, could you put a path there as well?
Yes, of course.
Okay.
This is relative. You can. I need to try it, but yeah, these are the kinds of things that you would probably want to experiment with, right? So I get my b.txt here, and I also get a.txt in my home directory, right? So be careful though. General rule of thumb, do not hard code long paths, or do not hard code paths in your output scripts, or in your scripts in general. It's better to have anything look at the it's better to go, create a directory, put your this directory should generally be in your home directory. Any data should be linked to that directory. We can talk about this some other time, hopefully, how you link your data. But generally, put your, whatever, if you have an executable or you have data, put it all together in one directory, maybe in your data directory, and then you go into that directory and submit from there, rather than try to hard code paths in your scripts. Reason being, it's easy to make mistakes if you're hard coding. And especially what you'll want to do is you'll probably want to run many experiments. and you will be copying that folder over, and having to go in and modify those hard-coded directories is going to be a pain. These will all come with experience. So 20 minutes to go. So we should be moving right along. So what would we may say next? Let's okay, I want to talk about two things. One is MPI, running an MPI job, like a very basic thing you can do with MPI, and also job arrays. Okay, let's try and spend maybe, but then I'd like to, allow for some questions. So let's quickly do OpenMPI and Intel MPI. Okay, let's do that. So let's pick another example. I will copy from my tutorial folder, Slurm, hello MPI. I'm just going to copy to my home directory. And you have a folder that contains these two files. Okay, one is the hello mpi.c file that is actually found on Wikipedia. Okay, it's just it's basically a hello world for MPI. You can I put it in that directory for you to easily access. I want to compile this executable. I'm not going to go into all the details of compilation or that, but what you need to know is that first I need a compiler. I do not want to use the system compiler. So if I say GCC here, if I have no module loaded, now if I say GCC, it will be using the system compiler. Don't do that. What we want to do is I want to use, for example, I want to use a very optimized compiler for the system. So I can load the Intel compiler. What this has done is loaded all of these libraries and compilers. So this is actually the name of the, this one. This is the actual C compiler. It also includes Intel MPI and Intel MKL. MKL is math kernel libraries from Intel. They are very optimized math libraries. More about this, I guess, in tomorrow's session. I'm not sure. So let's compile this. I should have it in my history, so we don't waste too much time. So I'm just saying MPI CC. Just want to compile the C file. I want the output executable to be named not a.out, but hello underscore MPI. And we have a compiled, this is our executable now. I can check also that it is a dynamically linked executable, right? And I have my job script. Sorry, Vim jobs, there you go. My job script is pretty much the same as before, right? It's kind of the same thing. I am not specifying how many nodes, by the way. Note this. I mean, I will do that later in a bit. I just want the output to go in output.out. I want, the job name should be MPI, right? I know it's going to run under a minute, so I'm just going to do that. I want to use this reservation. Now, this is very, very, very important. In my job script, I have to specify that I want to load the Intel module. If I don't, MPI run will not be found by my script, right? So please note this. This is very important. So what I'm going to do is submit. Now, the way that it works, let me clear this up a bit. Let me make this bigger. Whatever those commands, all of these commands before, all of these can also go on the command line. So I could have said sbatch, job name, blah, blah, output, blah, blah, whatever, reservation, blah, blah, okay? And then just send the script that it's open. What we want to do is actually put stuff in our script rather than on the command line. But sometimes it's not very convenient, so we might want to do. So reservation, I would probably want to keep on my command line and not put it in the script, okay? Because, I mean, you will generally wouldn't use a reservation, and when this reservation goes away, that job will not run. So just keep that in mind. Next, I can specify the number of nodes. I can say actual number full nodes. I can say 2 nodes. Actually, let's try and do 3 nodes. And then the name of my script. Now, my simple command, this script, was sent, and it will run on actually 3 nodes. We can already see some of the output. Now, because it automatically, spans and finds however MPI does this, right? It will actually go in and figure out how many CPUs are in there and run as many processes, and actually talks to Slurm about this. We have 40 cores on each of the nodes that we requested, and we have 3 of those nodes. That's why we have 120 processes. And that is your Hello World MPI. We have 10 minutes to go. We can either talk about job arrays as a way to automate, sending many jobs to the system. But I'd rather not do that. Let's, if you have a question about job arrays, send me an email and we can arrange another quick session. If you have jobs that you anticipate will take longer than 24 hours, again, we can do that later. So we only have 10 minutes to go, so I'd like to open up for questions. So Thierry, I'm not doing any presentations tomorrow, but it's really fun. I can send you, but I don't want to do that now. I'll send you a pointer to that. Once you get the jobs going, then you can figure out how to do job arrays. And if we don't have any questions, I can do that as well. Or I can start with job arrays and see if there are any questions.
George, can you hear
Yes.
me?
Yes.
What will happen if you, let's say, have a mistake in your script file and you send the job? How will you know that something went wrong?
Yes, I have a couple of questions on Slack, and I'll get to your question that I asked before, and I will get to you. Panayot asks, what's the difference between dash option and dash dash option? That is a general question about parameters in Linux in general. Generally, you don't want to use single dashes for let's say word arguments. You want double dashes for word arguments because to most programs, dash option with a single dash would say dash O, also dash P, also dash T, etc. But that's actually not really relevant to this subject here. Lefteris asks, so we cannot choose to use a specific number of cores. Will this be possible? Of course, you can use a specific number of cores as long as it's multiple of 40. But yes, I hear you, and I actually plan to. We are discussing internally whether to allow this. We have long what we call we never allowed what we call node sharing, because we were targeting big applications, and you don't want one user in the middle, working on the same node as another user, because generally users will use many nodes at a time. So, but there are many new applications that would actually benefit from node sharing, and that is something that we are looking at. And yeah, it's very possible. You cannot do that on our current system. We need to enable that, and that's kind of an internal discussion. But yes, it's very likely that this will happen soon. The question also from, if I remember correctly, was that what if you get an error, right? Well, if you have an error in your script will terminate. If you write your script well, it can terminate gracefully, and that's advanced bash scripting. In either case, the output, if you, let's do this, if you say this, dash error, oops, there you go. So output error, or you can say something like this. Then error will go into that directory. What I generally have, what I generally do myself is just use the same as output, so you get both of them together. So if your script terminates, whether that is successfully or unsuccessfully, that also means the end of your job. So you can ask for 24 hours and you submit a script that says just sleep for 60 seconds. After a minute, the script will terminate after 60 seconds. And then your job will terminate as well. I don't know if I answered your question.
Yes, thank you. And if you don't use the time duration because you don't know how long it will last, then what?
Well, if you overestimated the time, for example, you gave more time than your script will run, it's fine. You do not get charged for that or anything like that. You do not get accounted for that extra time, because those nodes are quickly given back to the system. So the opposite is a problem, right? If you have something that will run longer, for example, something that takes 30 hours to finish. It's a long, let's say, simulation. It takes 30 hours to finish. Actually, the maximum we allow in our system is 24 hours. You cannot run for 30 hours. Yet many of our scientists here, and we can talk more about that, is actually quite an advanced issue, can run simulations that goes for, months. And what they use what we call checkpointing, which means being able to save your simulations state, either frequently or based on a signal. Basically, you save your work and then you continue with your next piece of work. And then when that time runs out, you continue with the next, with another job, and on and on and on. That's where I really wanted to bring in arrays. But then we can do that some other time.
And George,
I
I'm
think there
referring
was
to
a
the
question, yes.
script. I'm referring to the script, not the system. Like if the script doesn't include the duration of the time, will it not run the job?
Oh, there's a
that is
default time.
submitted?
I'm not even sure what it is. Let's do
Mhm.
that. But no, let's not do that. Let's take another question.
Okay.
Any other questions?
Hi everyone. Just if I can interrupt a bit, I've put on Slack the link to our feedback form for today. If people can please take a minute to fill it in. Again, it's going to help us improve our training events for, well, the future training events. So it's on Slack, it's the latest message. Please fill it in. It only takes a minute.
If there are no more questions, can I quickly go over at least an introduction to arrays? Cool. No objections. So, by the way, somebody asked what is the default time, and the default time is 1 hour. Cool. Let's bring in the example with job arrays. Slurm job arrays. And I'll just copy that again to my home directory. I didn't use recursive. So here's my script. It's the same old script, but I'm doing a few things to it. Disregard this for now. But what I am saying is, instead of actually running a single job, I want you to run 5. And I want you to be running them one at a time. I can say, I want you to run these 1,000 jobs, but don't really blast the system, run them 10 at a time. So if I just submit this now, I can say SQ, minus L to get everything, but I can also get my own jobs only, right? So I don't have to, parse through the whole list every time. And I can do watch to keep running this command, so you don't have to repeat it all the time. So already, it's running on job 4, and now it's running the last one because I only had it sleep for 5, and I'm done. What this did is actually run that command, same job, 5 times. Every time it ran that job, I was accessing this environment variable. This environment variable was put in place by Slurm for my script to use, because then I know, okay, I'm doing task 4. So why don't I do just then I know I have the logic in my script. And this is not an entirely, simple thing. It's kind of an advanced thing to do, right? But I know what, based on this number, I know what I need to be doing. This can be used together, for example, with bash arrays, not Slurm arrays, right? Which we didn't go over, but you can have arrays, for example, in bash to pick the right arguments here. As with everything, and this is kind of my closing thing here, as with everything that we talked about today, this was not meant to be an end-to-end complete tutorial. I wanted to touch on as many things as possible, just to trigger people's thought, and to know that these things are possible with the system. A lot more are possible, of course, but at least these ones are the basic ones that can really help you. If you want to know more about anything, because I barely scratched the surface of pretty much everything. I have covered 1% of Slurm, 1% of bash. Really, I've done very little here. But you know that these things are out there, and then you can research them yourself. Now you know, for example, that arrays exists, so you don't have to manually create 100 jobs. You can use an array. If you have an issue with creating that, a problem, I would really love if you'd actually contacted us for help with that. Actually, we love doing this stuff. So with that, wow, one of the first times I ever finish on time, almost. Any final questions? Cool. Stelios, back to you. Oh, yeah. There is one question. There is one question.
Go ahead. Okay, Panagiotis, go ahead.
Sorry, can you explain the array syntax that you had there?
Yeah, this is pretty, there are many more things that you can do with arrays. If I just had this, that means 1 to 5, right? That's it. I would run this thing 5 times. If I do this, that means don't do them, but do them 2 at a time. Don't do all of them. Don't send all of them at once. There are a lot more things that you can do, and there are other ways to do job dependencies because you want this job to finish before that one, etc. If you want to look at dependencies more, check out Slurm dependencies. But this one I specifically wanted to mention because a lot of people, actually a lot of experienced people as well, are not entirely aware of this. So what they end up doing is they submit, because they will have a long-running simulation or whatever, they submit a bunch of jobs in the system, and they don't necessarily need to do that. So if you have a long-running simulation that does a part, saves a checkpoint, starts again, next job, next checkpoint, etc., and then they do it for however long it takes, you don't have to submit a huge number of jobs to do that. You can just submit a job array that with this and only allow 1 at a time to run. So you know that when your job finishes, another one will be submitted automatically using the same script. Just a different number here.
Is that %A what the array value is at each time?
Please repeat.
You have in your SBatch comments, you have output and you have %A.
Yes. This lowercase a is the step in the array. You can also have, for example, an uppercase A, like this, which is actually the job ID. This is the job step. There was another question. There is a the thing with the wall time is that it doesn't notify the dependence. The receiver, yes, go ahead.
If we submit a job and then submit another to execute it after the first one has finished.
Yes.
Okay, with with a dependency, then if it reaches the 24 hours or 1 hour, okay, wall time.
Yes.
It doesn't notify the dependent job. So it stays pending until you cancel it. This is something that I had tried once. This is one.
If I understand it correctly, this is a bug. If you saw this on our system, then we need to address it. Is this on our system? So you tried it on our system and it didn't work like that.
Well, it was about 1.5 months ago, so I don't know, maybe with the changes you did fix it.
Did you submit a bug for this?
No, because I didn't know if it was from my part or from the system's part.
If you don't know, we don't bite people's heads off when they send, right? So please submit a bug. Maybe it is from your side. Maybe that's something that we can help you with, or maybe it's from outside, in which case we have to fix.
Okay, I can try to recreate it, and if it still happens, I can. Yes, okay. Thank you.
Of course, excellent. Yes.
So for each of back to the array, just a quick question: Can I have a parameter changing according to my array step in the thing that I run? For example, I want to run a function that has a parameter, a given parameter, and I want to run 3 different simulations for three different values of that parameter.
Are you aware of bash arrays?
No.
Okay, quick one. Crash course on bash arrays. You can define an array in bash like this. Sorry, let's do it like this. A, B, C. Sorry, using that equal sign. And the way that you access, that's why I was insistent on you using curly braces, is like this, right? You can get all of the values like this. So what you can do, remember this Slurm array task ID? So if you had this defined somewhere early in your script or whatever, or you use a pull-in from another script, and you can do this. And you could basically access I think it's like this. I may be missing a so this will actually, now you have access to that value, and now you know which one you're in. Sorry. This is, yeah, something along these lines. If you check it out, it's going to be easy to find. Another question is that how to stop a pending or running job? Nice question. Let's get rid of this. SQ. You can do, it's called scancel. Okay, you can cancel your own jobs, but you cannot, of course, cancel other people's jobs. For example, if we have, I think it's pretty obvious. Actually, as cancel and the job ID. I'm not going to do that now. Actually, let's do that. Let's try and kill somebody else's job. As did I say SQ as cancel? Sorry. No, you cannot kill somebody else's job. Other questions?
There seem to be no more questions. So with this, I would like to thank George very, very much for his time and his wisdom and everything he's shown everyone today. As you've seen, he's only shown us the basics and the introduction of everything. And as you saw yesterday, there's a whole lot of things that you can learn. And as you will see tomorrow, where Jakob will show us parallel programming using OpenMP. You can get access to the system and an account, a proper account, not an educational account, through preparatory access that we showed you yesterday. And you can use the resources that the facility, the HPC facility has online in their wiki and on their website to understand more on the environment and on the queuing system. And as always, the guys over there at the facility are always present and willing to help you out so that you could learn more. That's what our job is, to help the community advance their skills and their competences. So please use the resources that are online. If you need extra help, send a message to HPC support, at cyi.ac.cy. And again, please fill in the questionnaire so that we know how well we did, and if you want things to be repeated. Also leave your comments if you want something extra to be shown in a possible future similar session that we will have. I will remind you again that we have a seminar in 45 minutes, the link of which, the Zoom link, will be different to what we used to connect to this meeting. I'll put it on Slack in about 10 minutes or so. Again, I would like to thank George for today.
Thank you all. It was nice having you. We should do this more often, actually. I think.
Yeah,
so.
we should. So that's why please fill in the response sheet for today, the response form, and tell us what else you would like such a similar session to include. And obviously, whenever we can have you present at the Institute, we will try and arrange something. Obviously, we'll arrange something for you to come, because having a hands-on session with trainers around and people physically being able to be at your side to help you is more efficient in helping you out. But at the moment we'll carry on like this until we can do so. So thank you for joining today. Thanks, George, again. And we'll see everyone tomorrow. I believe we start at 10. And it's going to be Jakob and Simone as well helping out. Again, it's going to be a hands-on session. So there's going to be theory coupled in with exercises on Cyclone. So tomorrow you're going to get to look at parallel programming. And the skills that you were taught today, you're going to use tomorrow and in the future. So thanks for joining, and we'll see each other. We'll see each other tomorrow. Thank you very much.
Thank you. Bye.
Bye.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Thank you.